this one. So now run the SQL. So you will get the age, area, and the department. So that's all about the basic SQL, basic queries of the in experiment number two. So now we'll move for the nested queries. So for nested queries, we have to create a two tables. For the two tables, we have to insert the values. So I will skip that content. So directly I will go with the nested queries manipulation, because you already know about how to create the table, how to insert the values. So I don't want to take much more time in that. So we'll move for directly for the nested queries. So here I have created the two tables. One is the STUD1. So this table consists of the serial name and then place. Okay. Here the present Anand Kumar Ravi, and then location has been given, place has been given. This is given in a one table. The second table consists of the name is the STUD2. STUD2. So here it consists of the name, department, and marks. Here the repeated content will be there. So why means so that only we can perform the nested queries and we will get the output. So that only some values has been repeating. Okay. So whenever you're going to create the tables means make it the same value should be repeated in one attribute or one column. So keep remember on that. So now we'll move for the execution. So nested queries, first nested queries. So I am going to execute only two queries because a lot of contents in experiment two. So I will make it one or two. So remaining thing you have to do it by yourself. Okay. So select name from the table number one, that is S student one, where student number one serial number should be in the select student number two S number from the student number two, because so inner query. So we are going to nested queries. It's an inner query. This one is the inner query. So this one is the outermost query. So I am going to perform the two queries, nested queries. Just I will make a run of it. So what here means, so I am going to get the values in the serial number should be in the same in the table one as well as in a table two. So what are the values having in the same value should be repeated in the student one and student two by using the queries. Just I am making a run of this SQL query. So I am getting the values of the three values has been repeating. So Prajan, Anand, and then Ravi. So here also same thing. Prajan, Anand, and then Ravi. So in table one also, table two also, it's repeating. So two things will be repeated. So nested queries within the queries. So next one, so it is inverse process of the previous one. In previous query, we have seen both the values should be present in both the tables. Here now inverse too. So the serial number is not in. In previous query, it will have only in. Okay. So now we are going to the not in means so inverse. It's an intersection like that. We have to in mathematical term. We can make it as an intersection. So intersection means both the things. Oh, sorry, not intersection. So values which is not present in both the tables. So distinct, unique one. So executing this query, so only Kumar. So Kumar values it is only in a student one. Okay. Suppose I will make it as the okay students. Now we can continue with the simple queries. Okay. So that will come under the experiment number two. So same thing. Now we are going to create the table. So it will have the serial number and then say ID, age, area, and department. So on corresponding data types and size will be mentioned. So here create table name. So create table name. So once it has been typed, just go with the run SQL. So successfully it has been executed. So at the end of the page, so we will have the attributes system name, the employee name, ID, age, area, department, and then empty. So after creating, you should insert the values as usual, same code. So insert into table name values. So you have to give the corresponding values which is given by the create table. Just give run SQL. So successfully completed. So it has been entered. So likewise, you have entered how much thing you have to enter into the values. You can enter it. So I have entered the four values. So that will have the name, ID, age, area, and then now display the table. Okay. So select star from the table name. So here you will get the table. So now we will move for the arithmetic operations. So here select serial number. So SID. So SID is this one. So we are going to perform the arithmetic operations. So based on the arithmetic values only we can perform this operation, not in a characterized data type. So keep remember. So SID plus 100. Okay. So STID from the student. Okay. So now I am going to execute this one. So just make a run SQL. So just see this output. So additionally you have the value. So initially, so you have the value as the 100, so plus 100, so you will get the 200. So instead of addition, you can make it as a subtraction also, just changing the plus by addition by subtraction. So again you execute it, so you will get the value as a like this. So this is the value we are getting. Okay, so next we are going to say about the displaying the distinct values. Select distinct. So from the tuple column erase the S area from the student table. Just select, just compile it. Sorry, run the SQL. So it will display the what are the attributes, S area attributes having the. So it's address. So Anna Nagar, Nungambakam, again Anna Nagar, and then Keelpark. So again the two Anna Nagar is there, but it will be considered as the only one. So replicate value has been removed. So next one, so group by. Okay, so select S area. So I'm going to select the area and then serial number, result from the student. Actually is a student, group by S area. Just make it an SQL. So you will get the output as the this result. So this result S area is the another thing. So result is this one. So result is the Anna Nagar from Anna Nagar Ashwin, then from Keelpark Chatrit, and then Nungampakam Bhavesh. So like that we will get the result. So we have taken only the four data. Next, by using the var class. Okay, select serial number and then name and then age. From the table name is a student. So var age is less than 19. So what are the data entered below 19? So it will be displayed. So I will make it as a 20. So next we will go for the join based queries. Okay, so here also we are going to create the two different types of tables, so that we can perform the join operation. So left join, outer join, so rightmost join. So like that we have to see. So we can see one by one. So here also we are created the two different tables. So first table name is a class A. So it consists of the ID, name, and then marks. The values has been inserted. Likewise for class B, so ID, address, age. So here keep remember, so two things are different. So that we can perform. So ID will be the remain in the both the classes. So class A and then class B. Two tables it is remaining. So remaining data is only the distinct. So name, here address, here marks, here ages. Okay. So now we'll go for the first natural join operation. So same, select star from class A. So I'm going to paste as a class A natural join with the class B. So this I will make a run of this query. So you will get the output like this. So here, remember here see, so the values which are present in the class A, so 101, 102 is present. The same thing will be repeated in the class B also. So 103 is present in the class A, but 103 is not, 103 data is not present in the class B. So this kind of output we will get. So this is a natural join. So once again I will repeat. So based on the class A will have the ID is the 101 and 102. Class B also having the ID 101 and 102. The two data is only going to be displayed as the output. So remaining data for the class A and class B will not be repeated. Just we will make it a small change. So I will make it as a, instead of class A by class B and a class B by class A. Okay, just I will make a one of this scale. So it is inverse one. So 101 and then 102. So base class B. So it will have it will not repeat. So both the values will have the same thing. Okay. The output remains for the if you inverse also it will be remains the same thing only. So next we will go for the cross join. So select star from a class A table, that is table name class A, cross join with the class B, that is table name 2. So just make a run of this one, so you will get the outputs. So each and every, so cross means, so class A will be uh, cross crossed by the, so class B. So 101 Abhirami 98. So it will go for the Trichy as well as Totim and then Namakal. So Abhirami, so marks is 98. So ID is 101 and then Trichy address and then 20. So same thing. So 101 98. So ID number is the 102. Here this one Totium and then Trichy. So 101 Abhirami 98 and then 104 Namakal 23. So likewise Abhirami 98, so ID number 105, it is Salem. So you will get the output like this. So next one for the RT. So 102. So it will 102 with the Trichy, Tottiyam, Namakkal, and then Salem. Next one for Babu. So for Babu also four more values will be get. So Trichy, Tottiyam, and then Namakkal. So each value should be Cartesian by the these four values. So totally 3 into 4 you will get the 12 outputs. So if you count means you will get the 12 outputs. So next we will see the left outer join. So how it works. So same, select star from the table name CA. So left outer join, that is object name. So the left outer join. So class B CB on a CA.id dot equal to CB.id. So now we'll execute this one. So we'll get the output like this. So base class a class A. So class table name is a class A. So class A will have the Abhirami, Aarti, and Babu. So corresponding marks will be there. So ID here 101 and 102. So these two things will be remaining same value. So now I will change the table name. I will make an interchange of the table name.